So the next thing we have to talk about when we talk about relativity, over the last of a couple of those portfolios, you've looked at time dilation, length contraction, momentum, and now energy. Now, first thing we need to do is we need to talk about the rest energy. Now, if you want to, not rest energy, total energy. The total energy of an object. That total energy is Einstein's most famous equation of all time and what most people remember. Okay? E equals mc squared. The energy that an object has is equal to mass times the speed of light squared. Okay? So that's the total energy that it begins with. That's how much it starts off with. Okay? So regardless of how fast an object moves, that's the amount of energy it has to play with. And that is kind of a really cool idea if you think about it. So an object is only going to be able to have that much energy. Okay? This E equals mc squared. A massive object is only going to have that much energy. So in order for an object to travel at the speed of light, that object has to be made of light, because that's the only way you can get the velocity high enough to travel at the speed of light, is if you have basically no more mass and nothing but light. Okay? So the kinetic equation for it, the energy kinetic, is equal to, well, we have this mc squared floating around, but we need to take into effect that there's a relativistic change there. That relativistic change is expressed as this gamma function minus 1. Okay? So that, excuse me, I'm tripping over my own stuff. That is the equation for the amount of kinetic energy that an object can have. So it's still holding on to its original value. It gains kinetic energy here, in a sense, emotional energy, and this is the original amount of energy. So it's stealing away from this term in order to gain kinetic energy. Okay? So that's the total amount of energy it has, the total amount that it can play with, and this is the total amount of energy that it's going to have via kinetic energy. Okay? So, in order for the object to travel the speed of light, that term has to go away. So it can't have any rest energy. So it can't be made of matter. Cool? So that is the basics of relativistic energy.